I'm going to go over the solutions to the problems on midterm review number 1, which is the Castlelearning review. This is the one that says page 1 of 5. So get the midterm review number 1 out. And try these problems on your own. And then when you get done with the problems and you've looked on the back and you have not gotten the right answer, then you can watch me go through the process. So on number 1, you're going to add 3 to both sides, and it becomes square root of 5x plus 2 is equal to 3. Square both sides, 5x plus 2 equals 9. Subtract 2, 5x equals 7, and divide both sides by 5, x equals 7 over 5, which is option 3. Number 2, product means multiply, and if you multiply two complex numbers, you have to FOIL them. So we have 8 plus 4i minus 6i minus 3i squared. Combine like terms, 8 minus 2i, and I squared is negative 1, so negative 3 times negative 1 is positive 3. So 8 plus 3 is 11, minus 2i is the answer, option 4. Substituting a 4 in for this x, we have 4 to the 1/2 plus 4 to the negative 2. 4 to the 1/2 is the square root of 4, which is 2. 4 to the negative 2 is 1 over 4 squared, which is 1 over 16. And 2 plus 1/16 is 2 and 1/16, option 2. Number 4. First of all, we have to find the sum of the two complex numbers. 6 plus 3 is 9. 4i minus 5i is negative I. This is just like graphing the point 9 comma negative 1, 9 and then negative 1. And if you were to graph, 9 comma negative 1, and if you were to graph the point 9, negative 1, it would end up down in quadrant 4. So it's just like graphing a point. The x value is the real part, the y value is the coefficient of I. In this case, it's negative 1. Number 5, you're going to split this into 2x plus 1 equals 9, and 2x plus 1 equals negative 9. Subtract 1, 2x equals 8, and x equals 4. And if you substitute it in, it will work, and check. This one you get 2x equals negative 10, so x equals negative 5. Plug it back in, and it checks. So 4 and negative 5 is the answer, option 3. The inverse means to switch x and y. So it would become x is equal to 3 over 2y. That's the inverse. And then you have to solve it for y. So to get rid of a 3/2, you multiply by 2/3, the reciprocal. So 2 over 3x is equal to y, which is option 1. Number 7, first we find g of negative 8. G of negative 8 is the cubed root of negative 8, which is negative 2. So then we find f of negative 2. So plugging in a negative 2 into this, you get negative 10 minus 2, which is negative 12. Number 8, you can't have an I in the denominator, so you have to multiply the given 5 over 3 plus I by the conjugate of the denominator, 3 minus I, over 3 minus I. And that becomes 5 times 3 minus I in the numerator. 3 times 3 is 9. I times negative I is negative I squared. This is 9 minus negative 1, which is equal to 10. And 5 over 10 becomes 1 over 2. So this is 3 over 2, because you do your little kidney bean thing, 3 over 2 minus I over 2. Well, I over 2 is the same thing as 1/2 I. So 3 over 2 minus 1/2 I would be the answer to this one, option 3. Which does not represent a function. It means it fails the VLT. Well, I would pick up my graphing calculator and put each one of these in. Y equals 4. Graphs on the graphing calculator is a horizontal line. That passes. Y equals x squared minus 4 graphs out to be a parabola. That passes. y equals x minus 4 turns out to be a straight diagonal line. That passes. X squared plus y squared equals 4 is a circle. The center's at 0, 0, and the radius is 2. Well, that is not a function because it fails the VLT, option 4. The product of the roots is equal to C over A. So in this case, A is 2, B is negative 1, C is negative 2. So negative 2 over 2 equals negative 1. Remember, product is C over A. So the answer is option 3. The roots of this quadratic equation, since they tell us it's A plus BI form, you're going to either have to use a quadratic formula or complete the square. Well, this is kind of written funny. So x squared equals 6x minus 10 is the problem. You have to set it equal to 0 because it's a quadratic, so subtract 6x from both sides and add 10. Since b is an even number, it's going to be faster for me to use complete the square to solve this rather than the quadratic formula. So we have x squared minus 6x plus blank equals negative 10 plus blank, because that 10 I just pushed back over. Half of b is negative 3. Negative 3 squared is 9. So I'm going to add 9 to both sides. Factor x minus 3 squared equals negative 1. Take the plus or minus square root of both sides, and you get x minus 3 equals plus or minus. The square root of negative 1 is I. And then you're going to add 3 to both sides, so x is equal to 3 plus or minus I would be your answer to number 11. Number 12, you're going to raise both sides to the reciprocal of that exponent because y is in the base. So the reciprocal of negative 1/2 is negative 2. So that will give you just a y on the outside. 1/3 to the negative 2, you can put it in your calculator if you want, or you can just flip 1/3 upside down and call it 3 over 1 to the positive 2, so y is equal to 9, option 3. The sum of the roots is negative b over a. So b is 6, negative b is negative 6, and a is 2, which the sum of the roots is negative 3, option 2. b squared minus 4ac is the discriminant. If the discriminant is negative, then the roots to a quadratic must be imaginary. Negative discriminant, imaginary roots. On this question, if the discriminant is 3, well, it's a positive number, not a perfect square, but not equal to 0 either. So they must be real and rational. They'd be real because it's positive and irrational because 3 is not a perfect square. If they were equal, it would mean the discriminant is 0. If they were imaginary, the discriminant is negative. This is not a perfect square. And if it's real and rational, it would mean the discriminant would have to be a perfect square. Make sure you know those classifications of a discriminant. In terms of I, again we have a quadratic formula that we're going to have to use. Let's see, I'll rewrite this. 2x squared minus 6x plus 5 equals 0. Set it equal to 0. Well, I'm not going to use complete the square because of this 2 as a coefficient of x squared. So I'm just going to do x equals negative b plus or minus the square root of b squared minus 4 times 2 is 8. 8 times 5 is 40. All over 2a. 2 times 2 is 4. 36 minus 40 is negative 4. So I'm kind of running out of room. I'll move this up here. Oh, there's the original quadratic formula. So 6 plus or minus the square root of negative 4 all over 2. The square root of negative 4 is 2i. 6 plus or minus 2i all over 2. Use my kidney beans or my heart-shaped thing. 6 over 2 is 3. plus or minus 2i over 2 is I. So this is 3 plus or minus 1i, or just 3 plus or minus I would be the answer. This one you have to rationalize the denominator, so you're going to multiply upstairs and downstairs of the numerator and denominator by 4 plus the square root of 13. So this becomes 5 times 4 plus the square root of 13 on the top, and in the bottom you have to multiply. 4 times 4 is 16, negative times positive is negative, square root of 13 times square root of 13 is 13. So 16 minus 13 is equal to 3. So now the next thing, I'm looking at the multiple choices, and it looks like they distributed the 5. So 5 times 4 is 20, plus 5 times the square root of 13 is 5 square root of 13. All over 3 is the answer. Looks like it's option 3. Now the inverse just means switch x and y, so I'm going to go through all those points and switch x and y, which means it's 3, 5, 4, negative 2, and negative 2, 7. Let's see if I can find that. 3, 5, 4, negative 2. Yep, option 3 has switched. Remember, inverse means switch x and y. Just something else for you to remember, switch x and y as in the inverse. We have a square root. 50 can be broken down into 25 times 2. Well, since this exponent is even and this exponent is even, we don't break that apart, so it's just r squared s to the 4th. So the perfect squares we take out are 25, that becomes a 5. R squared becomes an r, and s to the 4th becomes an s squared. On the outside we have 5r s squared, and on the inside we're just left with a 2, square root of 2, which is option 1. I to the 99th. Large powers of I, you have to divide 99 by 4. Long division, so it looks like you get 24 with a remainder of 3. But you don't care about the 24, you just care about the remainder of 3. So I to the 99 is I to the 3rd minus I to the 3rd, and I to the 3rd minus I to the 3rd is just 0, option 4. 1-to-1 function has to pass the HLT and the VLT. Well, this fails. This one, it looks like passes, option 3, because option 2 fails and option 4 fails. So option 3, 1-to-1, passes the horizontal line test. G of f of x. We're going to take f of x, which is 3x plus 5, and we're going to replace the x that I see here in the g function with 3x plus 5. So this becomes, instead of x squared, it becomes 3x plus 5 squared, and then I have to tack on a plus 1 at the end. Well, this is a FOIL, 3x plus 5 times 3x plus 5, tacking on a plus 1 at the end. This FOILed out is 9x squared. 15 plus 15 is 30x. 5 times 5 is 25, plus 1. And these are the like terms, so in the end we have 9x squared plus 30x plus 26, which is option 2. And then on the last page, we're going to square both sides if you have a radical equation. So that leaves us with x plus 6 is equal to x squared. Quadratic equation, set equal to 0. Subtract x and subtract 6 from each side. Factor x minus 3 times x plus 2. And x is equal to 3 and x is equal to negative 2. Well, when we plug these in to check it, the square root of 9 does equal 3, so 3 checks. But when we plug in negative 2, the square root of 4 is 2, but 2 is not equal to negative 2, so that one is extraneous. It doesn't check, and the only answer is option 3. 3. Looks like they want us to rewrite this in radical form. So a negative exponent means 1 over b to the positive 3/2. b to the positive 3/2 is the square root of b to the third power. Looks like option 2. Which is not a function. This would fail the VLT, vertical line test. Well, if I do a vertical line test on all of these, they pass. Now option 1 does not pass because if I put a vertical line right here, close to where it turns, then it's going to fail it. So option 1 is not a function, fails the VLT. And then the last question in this, we need to factor and cancel. Common factors, 9 minus x squared is difference of two perfect squares, 3 plus x times 3 minus x. In the denominator, we have a GCF of 2, and you're left with 5x squared minus 14x minus 3. This is a factor in, factor out. 5 times 3 is negative 15. Factors of negative 15 that add up to negative 14 are minus 15 and plus 1. So we have 5x minus 15, 5x plus 1. To factor that out, but you have to divide the whole thing out by 5, which is this factor over here. 5 over 5 is 1. 15 over 5 is 3. So I'm going to clean this up a little bit. The numerator still has 3 plus x times 3 minus x. The denominator still has the GCF of 2. And when I got done factor in, factor out, we had x minus 3 times 5x plus 1. 3 minus x and x minus 3 cancel out to a negative 1. So what we have is negative 1 times 3 plus x over 2 times 5x plus 1. Well, it looks like they want us to distribute the denominator, and it looks like they want us to multiply 3 plus x by negative 1, so that becomes negative 3 minus x on the top, and 2 times 5x is 10x, and 2 times 1 is 2. So negative 3 minus x all over 10x plus 2 is option 3. I'm going to create a second video that has midterm review number 2 on it, so you can view each one of these individually.